second session of our learnings of Python, and today we're going to cover collections and potentially go into Boolean logic and find out what is true in Python and what does that all mean. Alright, so let's go and switch into our screen. So we're going to get back to our Replit environment, and we're going to be working on Python collections. Don't forget that for one thing, you can type in the string that you see on your screen, help_collections with exclamation point starting it in Twitch. So if you were to type it in Twitch chat, you would be able to get instructions on how to start the whole process. And we're going to be going specifically in Replit and making sure that our configuration for run Python, let me see, I get some noise here, that our configuration for run Python runs python_collections.py, so that whenever we hit run, we're going to execute the code that we had within our file that we left off from. Let's take a look at Python collections. So last time we took a look at tuples, and I'll just quickly go through. We looked at how to create a tuple, how to create a tuple with a single member, the fact that tuple can have multiple elements in it, the fact that you cannot modify it, right? It's immutable, which is very important, quite helpful in a variety of situations. Gives us very nice restrictions. We looked at unrolling the tuple. So we have multiple values here. They unroll into individual values A, B, and C. And then we started on lists, and we went into creating an empty list, grabbing its type, looking at how we can create 20 elements of the same type that's producing a bunch of zeros. Looked at modifying individual elements so we can access it and modify it like you would expect with any normal array list with the various situations. And then we went through and looked at pile of different data within the list, just to see what we get happening there. Remembered about the none, that none is a separate type. I should have brought it up in variables, but we brought it up here. And then I did this little magic here with list comprehension. As I mentioned, we're going to go over it later. I just created it so that we could see various capabilities of list splicing, right? And so we looked at the list. We looked at getting, first 10 elements. So it's going to be up to 10 elements here. Then starting from 5th element on, grabbing between 5th and 12th element, grabbing every other element, which is looking at the step here, right? And then reverting list by looking at the negative step. The other important part that I haven't brought up in splicing is that you can have, I'm gonna step up here a little bit, and you can have this convenient element of grabbing, counting splicing from a different end. So you have an opportunity to grab, you have an opportunity to grab the last 5 elements. So you go, as we're looking, I believe this would be the right way. Let me just run it real quick to be sure. So we're looking at grabbing last 5 elements. So that was 4th one down. No, that doesn't look right. Sorry, sometimes you could get lost in this. Let me move it up to the top just to be a little bit clearer on this. Come on. Is my keyboard refusing to work? Of course, my keyboard is refusing to work. Sorry about that. Okay, of course I lost keyboard at the most inopportune moment. Keyboard off, keyboard on. connected. Yes. All right. So we're back. Let me grab it and put it to the top so that I could get. I'm on Mac. That's why Control X doesn't work. Okay. So let's put it on top. See what this does. So this gets So this gets up to. Fifth element from the end. So what I should have done, my apologies, is to do print sample and then get this. This would get me last 5 elements. So we're looking so we start our list 5 elements from the beginning to the end. That's the notation here. Here we're starting from the beginning up to 5 elements in. So if we want to grab a list, so this would be list of everything with up to 5 elements from the end. Not with, just up to 5 elements from the end, right? So if we don't know the length of the list and we want to exclude everything but 5 elements at the end, we would do this. If we want to grab the list and do last 5 elements no matter what, we would do this, right? So if we could end up with a list that was of variable length and we just need the last 5 elements of that, instead of doing the length minus plus whatever, we just go -5 to the end. And if we need to grab up to that spot, we can do this, right? And so this allows us to kind of do various crude splicing of the lists as we go there. Okay. So let me know if you guys have any questions, if you want to drop it in the chat and I'll just read it out or what have you. And so meanwhile, hopefully you captured that. So let's go to add list, append items to the list, and things of that nature. So with lists, we have an opportunity to tag lists to the end. That one goes relatively straightforward. So if we have simple list of 3, 4, 5, 6 and other list of 1, 5, 3, 7, something like that. Then if we do print of simple list plus other list, we are going to get, what are you doing? We are going to get a set of those lists added in order, right? So I have 3, 4, 5, 6, 1, 5, 3, 7. If I were to swap the order, I would obviously get them appended in reverse order. So that it allows you, so the plus sign is supported in context of lists. With sets it gets crazier. So here we'll take a look and we get 1, 5, 3, 7, 3, 4, 5, 6. Obviously this works that way. Let me take a look. I'm trying to think. So if you go with simple list and you want to add a value to it, I believe you just do add. And then let's do print simple list. Let's see if I remember that correctly. It is not add. Sorry, let me try. Okay, so it is append. So to attach an element to the end of the list, you could do append and it does, so append does operate on the list instance itself, and so it modifies the actual list instance itself. So the wild part about that is that if you pass a list into a function and you append on that list, you modify the list, the instance of the list that you passed into the function. So whoever hung on to that list outside would have that function, that instance modified. So it's very important to remember that you essentially have that list by reference and you are applying modifications to that list. So if you do list prepend, you get nothing because that doesn't exist. So yeah, so append allows you to do that. I believe you also have insert. Let me see. I'm just gonna do. Yes, you do have insert. I kind of had to grab a quick glance here. So you do have simple list insert, and you would put the ID of the element, and then you would put value. Value could be anything, right? So I'm dropping in a string, and so now it's value string added into the second element. And then, let me see, is it, sorry, now I have to find out Python list push. No, either way, let's try push, because there's some things I don't remember off the top of my head, unfortunately. And let's see, push. Let's try that real quick. No, doesn't exist either. Pop does exist, push doesn't. Either way. So, you know, there are a variety of ways to prepend. You can insert a zero and what have you. So let's go and look at a couple of interesting things that you could do with lists, because those tend to be quite useful within interview questions, exercises of various kinds, stuff like that. So you can have, imagine you want to generate random values, but you want to generate random values out of a predefined list. That is often useful, you know, rock, paper, scissors game, right? So let's go with that. So we're gonna go, we'll call the variable choices, and we're gonna go rock, comma, paper, comma, scissors. All right, so we got that. What we're going to do here, we're going to, from random, import choice. So this is, random is a standard Python library. So this is where we're kind of wandering into that. So we have this module called random that comes with instance of Python, any Python you would deploy. And choice is a function available there. So if you go choice, let's do this. Let's do print choice. Let's call it moves or something like that, just so that it's not that confusing. So we're gonna go with moves, and let's run this. So we have rock this time. So what it does, let's run it a couple of times. It's going to come up with various values depending on, yeah, we get paper sometimes. So this one particular allows you to pick a random value out of your available list, which is very convenient. And then you have another kind of powerhouse that actually ends up being a rather convenient capability for you know, variety of kind of tasks and questions, is shuffle. So we're going to import. So shuffle allows you to randomize the list. One thing to be cognizant about, this is yet another entity that would operate on your actual list instance. So let's go, I'm going to copy from above here. Where did I do that? List comprehension. So line 51, I'm going to just copy that line here, and I'm going to go in here to just create a clean instance. If only I remember to switch. All right, so I'm going to just create a clean instance of the list here, right, of sample list. And then I'm going to do shuffle. I did import. So another thing that I did here, right, on line 70, I went choice and then I went shuffle. So I imported library function choice and I imported function shuffle so that I could use it below. So if I do shuffle sample and then print sample and run this. So now I have, as you remembered, sample creates a list. So we can do this. Let's do this. Let's do print sample before shuffle and print sample after shuffle, right? So it creates a list of values that we need, right? The one thing that we're looking at is that we have, right, list starting at 5, 0, 17, 10. If we run it, it's going, we started with the same list, but it is going to modify it and produce a different set of results. The important thing to remember, again, is that shuffle actually operates on the list you pass in. So it's not a function that returns a list and leaves original list intact. It actually modifies your list, right? So that is kind of that. Let me know if you guys have any questions. And if you don't, we're going to descend into this fun and powerful tool called set. So I'm gonna give a little bit of break here. Let's see what's happening. All right, so sets are a powerful data structure that is common across multitude of libraries, right? The Java has it, Python has it, C# has it. Any really self-respecting language carries a set capability. The idea with sets is that a set can carry only a collection of unique values, and you are going to it allows you to create do you guys have issues hearing me? Yeah, on stream. On stream. I'm broadcasting on stream, and the other thing, just to give you a heads up, I am recording this, and I'm going to be recording every session just to make sure that you get access to it if you happen to miss something on stream. And I'm trying to push it out to YouTube the same evening, so you'll be able to get to it. And it's also a link on the page that you originally went to. There's a link at the bottom that gets you to the start of the playlist. So you'll be able to get through all that and have access to that. So let's take a look at sets. Yeah, so we have a notion of set to begin with. So interestingly enough, there's a bit of confusion between dictionaries and sets. There's no confusion for you now because you're new to it, but you'll see how there is a little bit of confusion once we get into this. So let's, so we're gonna call nice set, and we're gonna declare it. So you can declare a set by simply putting in two squiggly braces. If we were to print if we do print, Michael, I'll take a look at your question real quick. So if we print type nice set, we are going to eventually, when this thing runs, I don't know why it stopped. Can't have that happening. Can't have my running session stopping. All right, let's try this again. Okay, so this created as class dict. So that didn't quite work. So it defaults to dictionary, but we do declare sets in in squiggly braces. So if we want to create an empty one, similar to kind of the situation that was with tuple, if we create an empty one, we just do this. So we just declare set with open close parentheses. So nice set ends up being this, right? So I'm going to move this below just for posterity purposes that we go after the nodes. And then, however, you'll see right now, so if we do nicer set, that is going to be not empty. So I'm going to intentionally declare it with multiple values like that. And then I'm going to print nicer set here. So if you see when I declared it, right, I put in multiple values of different kind in there, which is kind of silly way to do it, but I did that anyways. And when I printed it, I actually just ended up with individual values individual values of different kind here. So yeah, that's kind of going into fitting list of repeating elements to a set. So we can go. Let's see. Yeah, I think I'm not going to elaborate much further on that. One of the consistent things that you can do, for example, so we can start with the list and then convert that into a set. So let's do our elements gonna be equal to probably double L, but I'm not just gonna worry about it. 1, 1, 2, 2, 2. So I'm just making a list of kind of jagged, not jagged, but the random values here. And then 2, 1. And so I'm going to print our elements just to show you how it is going to compact. What did I do here? I need to let me see. I need to print consistently here. Okay, so if we do that, so we got our list, right, of like strings and values like that, right? And so if I do print, and I'm going to convert list to a set by just declaring set with our elements list in it. So that's going to convert. It's going to take our list and it's going to convert it into a set. So it's not uncommon you would get a collection of certain things in the form of a list from somewhere, and you want to find unique values in them. So what you would do is you would grab that list and you literally just shove it into a set, and you end up with a nice unique set of values. So it basically ends up being a lossy conversion, because any duplicates you're going to lose, as you would see right now. I can't spell today, I apologize. So it's going to be a lossy conversion, right? Because we lost a number, one of the instances of number 2 and one of the instances of word 1 in it, right? Because it's a duplicate. That being said, we are getting only unique values out of that collection. There are plenty of instances where that is super valuable, right? So if you're analyzing a large text and you want to grab only unique words out of it, this would be the way to go if you just care about finding all the unique words that exist in there. Things of that nature. So there is another absolutely wonderful capability that set has. It allows you to do set math. So if you have two collections of elements that you need to get an intersect of, or a true grouping of, left side or the right side, one that exists in one and not the other, set is really irreplaceable, and that makes it a very nice trick for just variety of situations. So let's take a look at that. So I'm going to create, let's make test 1. That's going to be our first set that's going to contain 1, 2, 3, 4, 5, 6. And we are going to make test 2. That's going to be, let's go 3, 5, 6, 8, 9. Okay, so we have 2 sets. Let's take a look at various set math here. So let's start with minus. So we're gonna go print test 1 minus test 2. So we are looking at a set of values in test 1 that do not exist in test 2. Let's run that, and we get values 1, 2, and 4, right? So values 1, 2, and 4 do not exist in test 2. So this gives us the left outer join, I guess, or whatever you call it, right? So this is where you only get values that exist in test 1. If you go in reverse and you go print test 2 minus test 1, you're going to get values that exist in set 2 that do not exist in set 1. So you have an opportunity to just get something that's unique to one set or to the other. If we are looking at an overlap, right, because we're going Boolean logic here. So if we're looking at overlap, this is where we look at AND. So if we go print test 1 and test 2, we are going to look at an overlap between 2 elements. So this is, this is your what you call it, the Venn diagram. So this is your Venn diagram with an AND where the two populations overlap. So next we're going to be looking at our OR. So OR is the way to add both of the sets. You will end up with only unique values because a result of ORing sets is a set. So you're going to go print, and we're going to look at test 1 or test 2. Because the resulting value is a set, we are going to return 1, 2, 3, 4, 5, 6, 8, 9, right? Because that's the ORing of that. So all the elements that were overlapping in both would end up, our 3, 5, and 6 will only appear once here. And then the other one, that's kind of, it's one of those rare, but you're really happy you have it when you do, and that is our XOR. And so XOR allows you to take a look at everything that is in outer population here. So you get 1, 2, 4, 8, 9. So 1, 2, 4, 8, 9 are not present in any 1, 2, 4, 8, 9 are unique to each one of the sets, and so we have a resulting set that is not in both. Is not in both at the same time. Correct. Yes. So now I'm gonna pause to let you guys catch up and to ask any questions. I'm going to look meanwhile at the question that's already been asked. And that is, I'm just trying to think when tuple would be useful versus standard variables. They seem kind of restrictive, and they could get confusing to remember which value position you need at a given point. So that is absolutely correct. More often than not, tuples would be used in a more of a local situation where you need to extract you're traversing through some kind of structure, and you need to retract multiple pieces of data at the same time. Also, you have a good way, so we'll look at the dictionary. You have a good way of representing certain pieces of data as tuples. So for example, dictionary has your key and value. So if you want to grab one set of key and value paired out of it, which there are plenty of instances where you would want to do that, it actually comes back as a tuple that you can work with. So there are it is absolutely a special case, right? But there are plenty of special cases, and there are plenty of nice situations where getting a hold of a tuple of two related values is very valuable. And we'll actually, ironically, for loop commonly is a for each. We'll take a look at that, and this is where you extract values as a tuple. So let's take a look at the dictionary, right? So as you've seen, when we were trying to declare a set, that wasn't working very well for us when we assign it to squiggly braces. So let's take a look at, let's see how we're doing on time. Oh, we have plenty of time. Perfect. So let's take a look at declaring a dictionary, right? So dictionary type, fully spelled in Python, is dict. So it's dict, and you commonly get variable names ending with underscore dict as just a convention within Python. So we would go test dict would be, so if we start with an empty one, if we do print, squiggly braces default to a dictionary type upon assignment. So let's do this. Let's do print. I'm just going to add times 20 plus dictionary plus star times 20. So this should draw a nice pretty line for us here to kind of work with. Yeah, so my face is going to be all over this thing. I am going to transport myself to the other side live so that I'm not standing in the way of your knowledge, because that's not good. All right, so let's go back to this. So dictionaries. Trying to think. In the world of Java, they're known as maps, right? Hash maps, and so this is a capability to pair some kind of key values with some kind of keys with some kind of values, and you have a choice of what you want to carry in your keys. Interestingly enough, your keys do not have to be of the same type. So, you could have some keys as a string, some keys as an integer, some keys as whatever. The other aspect of it, key has to be hashable. So normally our immutable types work well. I mean, specifically any type that goes into that needs to be hashable. So what in the world that means, we're just going to experiment with it and see what's hashable by default and what's not, and kind of go from there. So let's take a look at declaring is, sample dict, me and with my imaginative names. So let's start with, I'm just gonna go kind of, on this two. Let's start with a simple one that's not particularly confusing. 3. Let's just do that. And we're going to print what we see here. So let's run and print that out, and we have our dictionary, which is 1 = 1, 2 = 2, 3 = 3. We can add an element on the fly to it by going sample dict 4, assign it a value of 4, and then if we print that, let's go next line. If we print that again, sample dict, we are going to get that element 4 added at the end there, right? So you literally just add a key and a value, and that gets attached to it. My apologies, let me move the comment above so that it's actually better aligned. So as you would imagine, accessing it, we would do it in the same fashion. We would we would access it by simply doing print. Let's print sample dict 2, and it is going to return a value of 2 for us. So you access it the way you would expect to access a dictionary. In that sense, it's not particularly magical. And then, so join dictionaries, not lists. So let's take a look at just adding one dictionary to another. So we have other dict, and we're going to, I'm going to be goofy here, and I'm going to go in reverse, and I'm going to say 1 is first, 2 is second. So just adding this list where you actually have keys in reverse here, and what I'm going to do is I'm going to say sample dict update with other dict, and then I'm going to print sample dict. So what's happening here, right? So as I mentioned, keys in that dictionary can be of any type. And so you have strings here 1, 2, 3, 4, and then you have values 1 and 2 that are actually integers that remain keys as well. And so if you wanted to access print sample dict 2, you are going to get answer second. Also, we're going to do just 1 for lulls so that we could cause an exception. If we are trying to get a value that a key that is not available and we run it, we get key error. So I'm gonna comment this one out and comment this one out, key error. So for right now, we're just going to another nuance here as far as overwriting elements, right? So let's see. Let me scroll down a little bit so you guys can see it a little bit better. So you can obviously overwrite elements. Dictionary itself is mutable, so you would go sample dict 3, right? We have that element is equal to 23, and if we do print sample dict, we're going to just do that. We are going to get a value 23 in element 3. So in its own right, dictionary is just a structure. It's not particularly magical. One of the things that you could do is if you're looking to aggregate unique values, and for example you want to keep count of them, or you want to keep some kind of association, dictionary is great. But it's, I mean, you'd probably learn similar things about hash map when you were going through that. So it's, dictionary is very much that. The only additional power that dictionary holds, just like lists, and I believe sets and tuples as well, is you can do list comprehension, you can do dictionary comprehension. We will touch on those once we start hitting loops, because you kind of need to have a little bit of background on how that happens. And so we'll do that within the context of that. And this is where the structures will kind of reveal their true power in that instance. I'm going to pause again and let you guys absorb dictionaries a little bit and ask questions, and let me know what's where. We have, it's 2:43, so I would say we have 15 more minutes. So the next section we're gonna hit on is establishing what is truth within within Python. And so I'm going to hit on a whole bunch of different elements there of which things are true and what we can check for in there. It's very nice to be able to, no, this moved to strings. Okay, so sorry, I do not remember. I wanted to hit Boolean next. Let me check that real quick. Substitute pi. Get. You see. Pi. This is Boolean logic. So that would be 1, 2, 3, 4, 5. Let's do this. So I'm gonna jump to that. Let's take a look at Boolean logic real quick as soon as that current topic is changing. I got it a little bit out of sequence there. All right, so with Boolean logic, going back to our configuration here, right? So we're looking at boolean_logic.py is the file we're going to be operating in. So the first thing we're going to do, we're going to go into REPL and then we're going to change this to Boolean logic and run it and see that it comes back empty and runs boolean logic.py. So with Boolean logic, the overall Boolean logic is not particularly interesting in many ways. The key what I wanted to touch on here is there are various shortcuts to quickly check if something is true, and I just wanted to show examples of what things evaluate to for different types depending on that type, right? And so we have covered enough elements here to start looking at that. So basic truthiness of values, right? So truthiness of values is if I happen to get that value, or if I happen to get a value or a type in a particular state, what does that evaluate to? Because that allows us to write a shorter if statement, right? That says instead of if blah equal to blah, we can just say if blah, right? And it goes to us. Let's get to what it actually means. So first we're going to check truthiness of int. So I'm going to check truthiness by converting it to Boolean. I believe this is all I need to do here. So I'm going to go with I'm just going to put literals in there. So I'm going to convert, as we know, if I just put a digit or a couple of digits without a dot in them, that would produce a Boolean value. So we're going to do Boolean value of 0. That's going to return false. If you're going to do print Boolean of 1, that's going to be equal to true. We're going to take a look at negative numbers, print Boolean of -1, that is going to be equal to true as well. And then if we're going to do print bool of 21, that's going to amount to true. So essentially when you have Boolean value of 0, this is the only time it is going to amount to false. So let's just do print integer truth, just to kind of get us clarity on where we are. So now let's do let's take a look at floats. So I'm gonna do print float truth, and let's take a look at boolean of 0.0. So we know when we declare a value with a dot in it, it is going to be of type float. So if we go with boolean equals 0.0, it is going to come back to false. To be honest, checking boolean value for truthiness, sorry, not boolean value, float value for truthiness is not a common practice, right? Because you could run into rounding off errors where something at the very edge would be equal to true, and so we'd rather not. Although Python does behave considerably harder on floats than JavaScript, so it's not going to be that, you know, the whatever bleeding edge point that we've experienced in JavaScript before. Like Python is very kind of strict. You subtract certain values from each other, it's going to be always on the nose 0.0 if it computes to that. So let's go take a look at print boolean 0.1. We're going to run into the fact that that is true. So anything that is not 0 is true. If we're going to go print bool negative 1.1, it's going to be true. So I think you get the gist here. Let's take a look at collections. So the cool part that Python lets you quickly check whether a collection is worth looking at or not. And for collections, we're going to go and basically, so yeah, I'm trying to basically do Boolean conversion instead of doing if statements yet. I mean, if statements are pretty straightforward, but since we haven't touched on them, I'm just doing Boolean conversion to show you what happens there. So if we do print collection truthiness, it's really truthiness, not truth. And truthiness is essentially verifying if something is true or false by converting it to Boolean and seeing what comes out of it. So if we take a look at collections, so let's start with lists. So if we do print Boolean of an empty list. So here, if we get an empty list, it comes back with false. So here's a tricky one. If we print a list that contains a value of false, a single value of false, it's going to be true. So that's something to watch out for, right? So what happens here is we are checking, sorry, let me put a comment. Is the list empty? Right, so that's what truthiness for the collections does. So even if you have a value of false in your collection, it doesn't care what it contains. It is important whether the collection is empty or not. Right, so we're gonna go through, let's put all the possible false values in here. We're gonna go 0, we're gonna go 0.0, right? Put all of those in there. Obviously it comes back with true because the list is not empty, so it doesn't matter what it contains. Kind of silly, kind of obvious, but important to know. Let's take a look at, same story is going to be with sets and everything else. So if we go Boolean, so if we have a variable, let's make a variable of empty set, just to see that it's going to be, you know, so it's an empty set. If we do Boolean of empty set, that's going to evaluate to false. And then, going through that, let's continue on with dictionary, print Boolean. You know, we're going to create an empty dictionary that's going to evaluate to false. If we're going to fill that dictionary with something valuable, obviously it's non-zero, you know, it's non-empty, so it is going to return true. So we did list, we did set, and we can do print, same goes for tuple, you know, empty tuple is going to return false, and if it's not empty, we're gonna go like 1, 2, 3, something like that in parentheses, right? So we declare the tuple, so that's going to be true because it's non-empty tuple. So that's a write-up for truthiness for collections. So I mean, as you see, it's a lot of little things that a lot of stuff in Python is really focused on brevity, and a lot of kind of these brief things mean something important in Python. And so we have an opportunity to check for truthiness of various things in there by just providing I'm going to drop an if statement there for like so let's declare did we have an empty let's make so we have empty dict equal, and just gonna make an empty dict, and then we're gonna write if not we're gonna do this dict is empty. Let's run it. Right, so the key idea here is we have some result coming back from somewhere, right? So the truthiness of the dictionary, if the dictionary is empty, the truthiness of an empty dictionary is false. And so if we do if not empty dict, so if truthiness is false, so false with not becomes true. And then if we go if not empty dict, so then print this dict as empty. So this way, again, this gives an opportunity for stopgaps to rapidly check for emptiness of certain values and not proceed with those values if they're empty. So we mentioned the value of none, so this is nothing equal to none. By the way, you might have noticed the way I named variables. Kind of having gone again, remembering, by the way, the variable section, right? So it is a Python convention to use lowercase snake case for variable names. So this underscore is underscore nothing is a Python convention of variable naming. Unlike Java, where you have, lower camel case, right? So you start with lowercase and then you go uppercase for everything else. And so yeah, Python convention, as you would see everywhere, is commonly this for variable names. Classes that once we touch on them are upper camel case, so it's everything is uppercase, essentially like you would see it in Java. But for variables, this is the convention, is to name variables this way. Let's see, so we got this. We checking for truthiness of it. So we're gonna print bool, this is nothing. And we're gonna take a break apparently here. What is this thing doing? All right, it's taking a nap. As you remember, the null permutation in Python, or rather null value in Python, is we use keyword none. My apologies. We use keyword none for a null type in Python, and so none would evaluate to false always. So if we do if this is nothing, it's going to be null. It's going to be evaluating to false. So that would be that. Now let's take a look. So we haven't touched string in the process. I'm going to just play with it a little bit here. We're going to go into more detail on what we can do with that. Right now we'll just deal with string literal, And so we're going to evaluate strings. Whenever a string comes back, we're going to do this. Let's do print boolean of empty string. So as you would probably guess, boolean of empty string would return false. So let's do the let's print string truthiness. See where we are on time. 2:58. Oh, we're coming really close. All right, so string truthiness. Let's take a look at this. Print boolean for empty string is gonna come back as false. Then we're gonna have print boolean for string that is not empty. I am not empty. Is gonna come back with true. So this one gives us a really quick switch on that one. And then we have a notion of undefined. So well, we don't really have a notion of undefined, because if I do that, this is not a variable, just because if we run that, we're gonna run into exception. So if we have that not declared, we're gonna run into exception. There is an opportunity to check for whether a particular variable exists. It's a function called local, and you can take a look at local variables that exist. So if you do print local, you are locals. My bad, it's plural, I believe. Locals. Yes, you're gonna get dump of all of them, and so you can check if that particular variable name. So that would be actually for strings the in that you would see below. Sorry, let me just do this real quick so we could wrap up in locals, so we can check if that particular variable exists in locals. And this is it's not done commonly, but you can check whether variable actually has been declared or used at any point. Usually just pay attention to code and write tests around the code to make sure it doesn't blow up. All right, so I'm gonna wrap up on this because this is on the edge of the hour, and we're going to finish up with truthiness next time and dive a little bit more into that, and then we'll probably jump over to strings and continue there. All right, thank you guys. I'm gonna